we went, but pretty much, so welcome guys. Just a little bit about me. So my name's Elise. I am a qualified heavy vehicle and plant. So I started out in road transport. I started on the red side. So I started at Cummins and I did my apprenticeship, so 4 years training there, and I spent a few months after that also at Cummins. Then I went into the ag side of things, where I was working for a small business doing field service, servicing farms, so pumps, irrigators, ag equipment, tractors, trucks, cars, whatever was on the farm that like moved in any way, shape or form. If it broke, we would try and fix it. And most of the time we would succeed. When we didn't succeed, it was usually because that machine should be going to scrap. But anyway, after that, I spent 2 years as a trainer and assessor for Westrac, which is one of the Caterpillar dealers here in Australia. So that was my first introduction to training and my first introduction to the cat world as well. I left cat about 3 months ago to start my own training and development company. So I do life coaching for tradies as well as technical training. Oh yeah, cool. I'm just watching everything as well. So that's just a bit about me and my background. So pretty much I come into the Caterpillar world a bit ahead of in the emissions kind of systems, because road transport is so far ahead. Well, in Australia anyway, road transport is regulated. The emissions standards are regulated, but still in the plant world over here, there's no regulations formally. Sometimes the owners of the mines will put regulations on the mine site, generally so that they can get approval from the government to then operate, to keep operating and keep digging into the ground. Pretty much, and some stuff in the tunnels and all that kind of stuff, like roadworks and all that kind of stuff, those sites will have their own emission standard, but there's nothing blanket across plant in Australia anyway. And I'm pretty sure that's the same for most of the world. I did try and do a bit of research and then ended up going down the rabbit hole of the internet while trying to find some more concrete information. I do have some of the standards and stuff, and we'll go through them in a minute. I'm just going to share my screen. So guys, this is interactive, so there is only a small group of us. So if you do have any questions, you can raise your hand with the raise your hand button, or you can comment in the chat with your question. I do have, so like I said to some of the guys before, when I run an emissions course, when I was training with Kat, I do it over 4 days. Roughly 1 day worth of theory, 3 days worth of prac. I've got a lot of the same content, similar content. I've cut out some of the stuff that I thought wasn't directly related into what you do on the tools every day. And I have put in a bit of fault finding at the end. So if we do get into that before the end, like if we still got time left, we can go through that fault finding stuff as well. If not, then I'm hoping to do another webinar on that as well. So I'm just going to share my screen because I've got some images and stuff that I'd love to share with you guys. Let's bring that over to this side. So I want to share screen one. I feel like I'm just going to share this with you guys. Cool. Minimize that, and I'm going to bring you guys back up so I can see if you put anything in the chat as well. While I was doing COVID, I did run a few classes online, so I wasn't too worried about the online format. It is a bit different for everyone. I do prefer face-to-face, let's be honest. It is nice to get hands-on. So yeah, welcome to our introductions to emission control systems. So is this going to look over? Cool. So what are emissions? So for a lot of us, there is a lot of different chemicals that do come out of our engine. Yeah, so there is a lot of different the chemicals that come out of our engines, but the two that we focus on with our emission standards and our emission control systems are NOx, or oxides of nitrogen. And here's just a bit of information about NOx, so then we know how it gets to be there and why the governments and the regulations are so, they're really targeting NOx. So the oxides of nitrogens are a mix of gases that are composed of nitrogen and oxygen to form when fuel is burned at high temperature. So we know that our combustion temperature is like 600 plus degrees generally. So when we have that high temperature of combustion, NOx is created. Don't worry about that. So if we have too much nitrogen dioxide or NOx in our bodies, so if we as humans breathe it in, it can damage our respiratory tract and increase the severity of respiratory infection, asthma, and we can get chronic lung disease as well. And NOx causes smog and also acid rain. Acid rain, not really something that we really like. The other pollutant that we focus on, or that the industry is focusing on to get rid of from our engines, is particulate matter. So particulate matter is solid and liquid particles suspended in air. Pretty much they're formed in the incomplete combustion. So at a low temperature combustion, so on startup, we usually get a bit of black smoke on that gear change when our revs fluctuate a lot. We get incomplete combustion, which then forms particulate matter. So there's a whole heap of other chemicals that also come out of our exhaust, but they're the most important. And also particulate matter is pretty much anything you can see coming out of the exhaust pipe. So yeah, there are two main ones that we focus on. Across the countries, there's heaps of different standards. So the two that are most commonly thrown around is the Euro standard. So last I checked up, the Euro 6D was released in January 2020. And that was the latest one for the Euro standards. And then for the US, the latest is Tier 4 Final, which in the CAT world, we know that our different systems, we refer to them as Tier 4 Final kind of thing. And they were phased in between 2012 and 2015, and there hasn't been any formal updates since then. Japan also has a kind of ruling system as well, but I could not find anything that was really solid in that as well. Information, there wasn't anything that was very clear, and I was kind of just getting lost in the rabbit hole of the internet trying to find out some more information about that. But yeah, the Euro and the tier kind of standards are the ones that we come across most commonly. Cool. So in our phasing, so guys who've worked with CAT, you might have seen these images before. But with our Tier 4, our Tier 1, that kind of started kicking in between 1996 and 1999. And we can see here they've got, for different horsepower ratings, they have different standards as well, because we know with different horsepower ratings, more fuel's burnt, different temperatures, different size, and also different purpose of what those engines are used for and how common they are. So that all has an impact. So they have divided into 4 horsepower ranges, and they all have slightly different standards. Along the side here, they're focusing on particulate matter, and then along the bottom, we're focusing on NOx. So that was between 1996 and 99. Then if we go to our Tier 2 or our Stage 2, that kind of kicked in and phased in between 2001 and 2004. We can see that we have cut down on our particulate matter a lot. So in that phase, we've kind of focused on what the engines can do and the engine control, so our timing and our the quality of our fuel and all that kind of stuff, the quality or the effectiveness of our injectors, and adding computer systems onto our engine. So when we've got heaps of different sensors that are monitoring temperatures and all that kind of stuff to make sure that we're having the right amount of fuel go in. Having those controls over a full mechanical engine really brought the particulate matter down. So in that tier 2 stage, they were really focusing on that particulate matter. We go into tier 3, they're really focusing on NOx here. So tier 3 happened between 2006 and 2008. And for the CAT guys, this is kind of when ACERT, tier 2 and tier 3 is like that really ACERT kind of phase. And that's when we started focusing on NOx. So for a lot of manufacturers in this tier 3 stage is when EGR or NRS kicked in. And that's where we really started seeing it on our engines. Alrighty. And we've got our tier 4 interim. So comparing it to the last lot, everything's kind of come down more, but they've focused back on the particulate matter, bringing that down again. And then with our tier 4 final, we've pretty much gone to literally almost nothing. We've just got this range here, which is our 174 to 75 horsepower range. I don't know, is that? No, that's a different color. They're not in the same order here. So our 750 and above horsepower, we still don't have as fine a tolerance on NOx there, but everything else is pretty much back down to nothing. So over the years, they couldn't just bring in like smack bang tier 4 final, everyone would go broke. So they phased it out over 20 years or so, and now we're at our tier 4 final stage. So we're going to talk first about EGR, so exhaust gas recirculation, or NRS, NOx reduction systems. So CAT generally call it NRS because they did this big hate on EGR when it came out, and then they decided to just name it something different. So NRS and EGR are used interchangeably because they are pretty much the same system. Alrighty, so what do you guys know about EGR? So there is a few different myths about EGR. I think it might just be, we'll just talk about it at the end. But one of the biggest myths is that the EGR is, the purpose of EGR is to cool down, or to, not to cool down, to reburn the air. So you're trying to reburn the burnt air. So lots of people have said, yeah, EGR just burns the air again to make it cleaner. But can you burn something that's already burnt? So with EGR, the purpose of it is to put the burnt gas in to the cylinder that can't be combusted. So it's taking up space in there, which then makes a cooler combustion. So when we have a cooler combustion, we don't have as much NOx produced because NOx is produced when our temperatures are high. So we put in burnt gas that can't be burnt, which is taking up space. And what that does is, we're just emitting a few people. So what that is creates a cooler temperature. We don't have as much oxygen in there, so we don't get as much burn. So that's pretty much what our EGR system is doing. It's creating a cooler combustion to reduce NOx. So as you know, if we've got a cooler combustion, then obviously it's not as clean because we want to have a nice, hot, clean burn. That's what gives us the most power and the less particulate matter. So it's kind of like when you're starting a fire and when it's starting to warm up, you get heaps of smoke coming out of it because it's too cold. As the fire is burning really hot, you seem to get less smoke. That's because everything is burning really well, but at that high temperature, instead of getting smoke, you're getting NOx instead. All right, so yeah, the idea of EGR is to dilute the intake charge air with dead gas that will make a percentage of the cylinder volume unreactive. So the idea is to reduce NOx emissions by lowering combustion heat. The downside to this is that as that occurs at the expense of power and fuel efficiency, and also raises particulate matter. So EGR is a method of reducing pre-emissions emissions at the source. So when we refer to emission reduction systems, we've got pre-emissions, so pretty much trying to stop the emissions before it leaves the engine. And then you've got our, what we refer to generally as after treatment. So anything that happens after it's gone through the engine. So anything that we pretty much whack on the exhaust. All right, so we've got our basic components. So across all manufacturers, we generally have the same basic components, just slightly different styles and locations. So we've got our piping, we've got our EGR cooler, our EGR valve, and then we have some way for it to get into the intake. So our exhaust piping is generally slightly different on the EGR engine, and our intake piping is slightly different. Pretty much the only things that are added on is the cooler and the valve. That are major components. All right, so our EGR cooler is a heat exchanger. So most of the time we've got coolant running next to the exhaust gas to cool it down, to bring it back to a temperature that is closer to the intake temperature. Generally, we've got a few different styles. I have some photos coming up in a few slides of some different ones. All right, so then we've got our EGR valve, so ECM controlled mixing chamber. So that's when we're mixing our boost air from the turbo with our exhaust gas. So our EGR valve controls how much burnt gas is going to go back in. We've got our mass airflow sensor. We've got our EGR coolant pipe, so getting coolant to that cooler, our air piping, and our mixing pipes. So our mixing chamber is generally what we refer to as the space just before or when our exhaust gas is mixing with our intake. All right, so we're going to go into each of these a little bit further. So with our EGR or NRS coolers, we've got a few different styles. So the Cummins one, we've got a long cylinder along there where our exhaust gas goes through and coolant goes through as well. On our Detroit style engines, it's a slightly different, kind of looks a little bit like an oil filter or an oil cooler sitting on the side of the engine. But this is our EGR cooler, so it's more of a cylinder shape. And then we've got a smaller one here. So this is something typically that will be on a smaller engine. And then we've got here, this is a CAT style one as well. So up here in this system. So Cummins for some reason opted to go sit it below the exhaust manifold, and CAT has sat it on top of the exhaust manifold. Not in all systems, but generally speaking. All right, so our EGR and our NRS valves. So this one is off a Cummins 15-litre engine here, and then we've got this one is more of a CAT style one. So they both have a different style poppet valve in here, and these two in the images are electronically controlled. So in most systems, our EGR valves are electronically controlled, so a solenoid that is opening our poppet valve to a certain amount to allow a calculated amount of exhaust gas to go into our intake. Some of our CAT systems, so I've only ever seen it on CAT systems, some of their EGR valves are hydraulically actuated with engine oil. So that's a different type of system again. So it's pretty much the same thing. There's a poppet valve, but instead of having an electronic solenoid on there, it's got engine oil under pressure. It sends it to it. It has a solenoid that controls the oil that goes there. So it's pretty much just a vice versa way of doing it. But the idea of that is to keep the electronics away from the heat of the exhaust system, and then you just have hydraulic oil opening and closing that valve. So there's two different terminologies that we can use for our EGR valves or our NRS valves. They can be hot side or they can be cold side. And what that pretty much just refers to is whether or not they are before or after the EGR cooler. So they're generally not too different in the way that they're built. The ones on the hot side will be obviously a little bit more rugged and able to take more heat. All the ones that I've seen have been on the cold side. Just seems to last a little bit longer and is a bit easier on the components. Cool, so our EGR mixing pipes. So there's a few different styles of EGR mixing pipes. So when we refer to mixing pipes, we're talking about where our exhaust gas meets our intake gas, our fresh air. So pretty much some of the systems are created as a venturi. So pretty much as our intake air comes past the opening, it creates a negative pressure, which then draws in the exhaust gas. Because our intake air is boosted, it's got a higher pressure than our exhaust gas. Our exhaust gas is kind of just chilling through there. It hasn't gone through the turbo. It's not boosted or anything. It's just kind of coming around. So in any situation, if you've got a high pressure and a low pressure, there's no reason for the low pressure to enter the stream of the high pressure. If anything, that high pressure will then start to overtake the low pressure side. But the way that the engineers have designed these systems, it creates a venturi effect, which is then creating that negative pressure, which is then sucking that air through or drawing it through, allowing it to mix with the intake air. This red one here, obviously red, we've got some common stuff. And then we've got our reed valve style. So the reed valve style are pretty common on the smaller cat engines I've seen. So pretty much the idea that we can push air through, so it's quite a low pressure that can come through, but as soon as anything is pushing on the other side, it can't enter back in. So quite a simple, easy way to have that going on. Doesn't take up too much space. You just kind of need that intake manifold and then chuck those reed valves in. So not too consuming of space. Cool. All right, so our mass airflow sensor. So in our systems, in our emission systems, our mass airflow sensor or our MAP sensor or our MAF sensor, you know, whatever you want to call it, is pretty much there. So we're seeing how much pressure is going into our, or how much air is flowing into our engine. So if we're putting exhaust gas in or burnt gas in, we're not going to have as much fresh air going in. So pretty much our sensors will, the ECM will be able to get the information of the sensor, and it'll be able to see that there's less fresh air going in, which means our EGR valve has successfully opened. If our EGR valve doesn't successfully open, so if it gets blocked, then we won't have any air going through. So our ECM will be sending a command to our EGR valve, and it's telling it to open. So the ECM knows that our EGR valve should be open, and we should be seeing a drop of fresh air at our mass airflow sensor. If the ECM doesn't see that drop at the mass airflow sensor, then it knows that there's something wrong and will bring up a code. Alrighty, so that is a quick overview of EGR, what it is, and how it works. So EGR is probably one of our most common things that's been around for a while, and in the process of upping our standards, engine manufacturers have opted into it and then opted out and opted in. Depends on what we can, depends what the manufacturer decides was better off. Cool. Righty. So next thing we're going to talk about is diesel particulate filters, or DPFs. So we generally see DPFs on systems that do have EGR. So like we said before, yeah, so Sergio, yeah, it's all for diesel. So all this stuff is referred to diesel. Cool, I'm just going to angle that up so I can see your messages a bit better. So diesel particulate filters. So we were referring before to how when we reduce the temperature of our combustion, we get less NOx, but having a reduced temperature also means that we don't have as much of a clean burn. So that also means that we raise the amount of particulate matter that we get. So if we've got a higher temperature burn, we don't get as much particulate matter, but we get more NOx. So EGR and DPF are generally used side by side because we're lowering the amount of NOx at the source in the engine, but we're increasing particulate matter, so we need something to collect that particulate matter. All right. So the diesel particulate matter, the idea is that it catches anything solid that is coming out of our engine. So anything that we can see should be caught in the DPF. So pretty much there's a little kind of saying with DPF. So if you've got an engine or a machine with DPF, if it's smoking, it's broken. All right, so in the system somewhere, if you see smoke coming out of the exhaust pipe, there's something wrong with the DPF. And the DPF might not be at fault. It might be blocked or it might have been cracked from a shock coming through the engine. But definitely if you see smoke coming out or steam or anything, there's something wrong with the DPF straight away. So with our DPF filters, they're not a flow-through device. So you can't just get a piece of wire and stick it straight through our DPF. They're actually got kind of like a honeycomb kind of setting. And if you look at the DPF on one, like it's a checkered pattern. So it's kind of like one closed, one open, one closed, one open. And if you flip it around, it's actually the opposite. So the ones that were closed on one side are open on the other side. So what that does is as it goes through, as the air goes through, the particulate matters will be caught in, so you can see it here, the particulate matter will be caught against the block, but the walls of the DPF are actually fine enough that so they're made out of ceramics, which allows the air to flow through. So nothing solid can flow through, but the air can. So as it catches, it'll build up, build up, build up, build up, build up, and the air can still just keep going through. Right. All right. So regeneration. So what would be the ideal chemical to clean situation? You can't replace it. So Shandy, the ideal way to kind of clean it would just be to blow it out, pretty much just opposite way. Or there is a few different machines or equipment that you can get to blow it out that use like ultrasonic vibrations. But generally, like if you're on the side of the road and you're just trying to get old mate going, blow through the other way, or you can wash it out in the field, yeah. So in the field, just flip it over and try and blow it through. Or you can wash it out with water. You don't want to put any extra chemicals on that surface because then it won't allow it to regen properly and you'll just get another fault that way. So if anything, you just want to kind of be as pure as you can, air and just water, and then allow the engine to run and heat up and then allow all that water to evaporate out of it. But you kind of don't want to add any extra chemicals into that can get stuck on those walls. All right. So a burn, I hope that answered your question. All good. So with our regeneration, so pretty much that is a burn that's done when our DPF reaches a certain level. You're blowing through. I'm not sure what the ideal air pressure, but generally just go with like just start low, and you don't want to, if nothing's coming out, you just want to slowly up it. You don't want to damage the honeycomb wall. So yeah, I don't have an exact air pressure for you. All right, so our regen is our burn. So pretty much all different engine sizes and different engine models and makes have a different ideal temperature for their engine to do a regen. So I call them regens or a burn. But pretty much the idea of a regeneration, what's happening is that those tubes that were blocked that we saw in our last, let's go back. Yeah, so these tubes that are blocked here, they get built up, build up, build up. So they get built up with soot, or if you want to get really technical, you can break soot down into many different things. But for the example of this and ease of explaining, so we'll pretty much call everything that we can see pretty much soot. So soot will build up in those walls, and what will happen is that it will slowly get blocked. So the engines or the ECMs generally use pressure differential sensors, or some of them use sonar to see how full our DPF is. And what happens is after that, it'll get a reading. It'll kind of change the running conditions of the engine to then bring up the heat of the DPF, which will then cause the soot to burn off. So what happens is that our soot burns off and it becomes water vapor and something else that I can't remember off the top of my head, but it burns off. But you're still left with ash. So when we've got a little campfire, we can burn and burn and burn as much as we want, but we still get that grey ash at the bottom. And what that is, so ash can't be burnt. So what happens is that just stays there. There's nothing we can do with the ash. So we can burn soot, we can reburn it and bring that down. Oh yeah, well it says here, converts the soot to carbon dioxide and water. But anyway, but yeah, our ash can be removed with a service tool as well, but we can't burn ash. So there's always going to be something kind of slowly building up there. So we can have a full DPF, we can burn it down to pretty much nothing, but there's still a slight amount of ash in there. So that what that means is that over time, even if our engines are running perfectly, we will still get a small amount of ash building up. All right, so there's a few different types of regens. Well, there's more than a few. If you look into the world of regens and how regens happen, you can just go down the massive rabbit hole of different styles of regen. But I've broken them down into a few different types that are quite easy to kind of get your head around. So we've got passive regens. So passive regens happen naturally. So passive, so it's kind of something that you don't really notice. When an engine is operating under load, so we've got, you know, heaps of fuel pumping in, heaps of heat coming out, it can remove the soot naturally because that temperature has been reached to then burn the soot off. So pretty much all DPF systems have some type of passive regen, so they can, if they're really working hard, they'll get the exhaust up to that temperature to do a burn naturally. Then we've got an active regen, so that's like when a small amount of additional diesel fuel is injected on the exhaust stroke and is used to increase exhaust temperature, or that's what we're going to go into ARD heads or after treatment regeneration devices in the next slide or the slide after that. Or there's something in the system that helps raise the temperature up. Best of emissions engines, high loads are best of emissions. Yeah, so we want to make sure we have high loads. So story time. We had this customer when we were at Cummins. He was carting around, he was doing recycling, so he was carting around cardboard, and he had brought an engine with a DPF on it. This DPF was shitting itself all the time. Because he was carrying around cardboard, he'd have a lot of that volume, but not a lot of weight. So that engine wasn't able to do passive regens all the time, and that DPF would just shit itself all the time. We'd have, you know, it would just be flashing codes left, right, and center because it couldn't do what it was meant to do. It wasn't running with that amount of load that it was designed to run with. So yeah, high loads are best, especially in our heavy machines, to burn off stuff. So our active regenerations is something, yeah, our engine does some kind of thing to bring up that exhaust temp. So generally, if you're driving a small truck or something that has regen, as you put your foot down and you're on the highway, you kind of, if you're listening, you can notice a change in the note of the engine, or like a bit of a change in the power kind of thing, because that is putting, it's just adjusting fuel air ratios, it's kicking in an injector or something to bring up the heat. Then we can have operator induced. So that's when, you know, our operator can park up, or sometimes these can be done while it's working, flick the switch in the cab, and it can start or stop a regen. A lot of people ask, why do we even have this switch in here? Because operators just like keep stopping the regens, and then the filter gets blocked up, and then it shits itself, and they can't operate anymore. And then we have to go out and fix it. But the reason why we need to have the stop switch in there is because if this machine is operating in a situation where we don't want that regen, we can't afford to have that excessive heat. If it's operating in long grass, in the forest somewhere, cutting woods, you know, recycling center with paper or like garbage around. We can't afford to have that heat in that environment, so we have to be able to stop it. The idea is that if the operator stops it, they need to park it somewhere else and allow it to do that regen. But a lot of operators haven't been told this for some reason in their training, and then they just keep stopping and never allow it to do. So ECM induced, so if the ECM is just kind of, is there any possibility that this filter gets stuck? If yes, can we change it or use the cleaning system? So at the end, is there any possibility that this filter can get stuck? If yes, can we change it or use the cleaning system? Yeah, so you should be able, if it gets full, you should be able to like dodgy clean it out on the side of the road. But the filters generally, because the ash is packed in so fine, you do either have to change it or send it away to get professionally cleaned to have a long-term solution. So with our ECM-induced regens, the ECM is kind of just monitoring all our temperatures and, you know, how the machine's been operating for the last half an hour or so. And if it sees everything like met perfectly, it'll start doing a regen. It'll just up its temps by controlling the air-fuel ratio. And it's very similar to an active regen. But the ECM is like, yeah, you know, we don't have to do much to get this to work right now. And then we have our diagnostic regens. So pretty much when we plug in with ET or Insight, our scan tool, we can sit there and we can do a regen. That's just another form of active regen. Operator induced or ECM induced, they're all very similar. It's more just like the way that they're starting. But we can do regens just, you know, standing there with our laptop, and we can watch it do for the reason of diagnostics. If you really wanted to go down, there is like 5 different types of passive, 10 different types of active, you know, they just go on forever and ever. Each manufacturer has something slightly different that they do. All right, so we've got our different warning levels. So our operators will have different levels of warning that they'll be able to get to be like, well, mate, you need to do a regen. There's something wrong here. As we go up, it will slowly disable what type of regen you can do, just because the ECM will not be, or the DPF won't be able to do that regen safely. And it has different types of, so this warning system is actually from CAT, but each manufacturer will have a similar thing. It'll reach a certain percentage and it won't be able to do a low temperature or a passive regen on its own. It'll just, like, nothing will happen. So as we get up higher, so for this example, at 116%, we'd have a D rate, and then we'll have a level 2 event. And then at 127%, we'll have an alarm, a D rate, a level 3 event. So a lot of these things are slowly, so the engine will D rate 25%, 50%, 75%. And then you'll only be able to, on some equipment, you'll only be able to start and run the machine for 30 seconds. And then you can keep running the machine for 30 seconds. So the idea of being able to run it for at least 30 seconds is that you can get it off like a haul road or a main road or out of danger. Otherwise, you're not going to be able to operate it because old mate's been too stubborn and, you know, hasn't got this sorted out earlier. All right, so raising the heat. So with this there's different types of active regeneration devices. So for the CAT world, there are ARD heads. Mac also has a similar system that's just kind of like in a different configuration. But pretty much the idea of this is to raise the heat. And with our ARD heads, they're pretty much just like a little motorbike engine. That's the way that I like to explain them. So they're pretty much a little cylinder head. And they've got a spark plug, they've got clean air going in, and they have fuel going in. So pretty much if you took the exhaust off and just had the ARD head in there, obviously your sensors and all that kind of thing wouldn't let you run. But if you could run it, it'll literally just be a flamethrower. It's just throwing out this massive amount of heat that is caused by that little combustion that is happening in the exhaust stream. So pretty much ARD heads or after treatment regeneration devices are put on systems where it's very unlikely that they're going to meet the temperature on their own. So if they're always if it's a generator or a small excavator or, larger equipment that it's like, cool, the way that we've put this engine together, it's not going to be able to adjust the air-fuel ratio on its own to then bring the temperatures up. So they whack on one of these ARD heads. For those who've worked on them, when they first come out, the CAT system with the ARD head, I'm pretty sure everyone just wanted to burn the machines to the ground. They weren't too great at the beginning. With our after-treatment regeneration devices, because we've got a combustion event going on, we need fresh air. So that fresh air comes from our combustion air valve, which pretty much is a pipe coming off our intake over to our ARD head, and it's got just a butterfly valve opening and closing, allowing it to flow into that exhaust. It's not flowing into the exhaust, it's flowing into where that ARD head is, ready for it to be combusted. All right, and then we've got fuel going in. So the fuels going in can either be done by an electric pump or just coming off the main fuel system and having a little solenoid there that allows it to come off. So this one's got an electric pump on it. This one's quite common. This is a CAT one. Then this number 2 here is a pressure regulator. So pretty much this fuel system on our ARD head is just like any other fuel system you'll come across. It's got a pump that creates pressure, and obviously when we have pressure, we need a pressure relief valve, because obviously if we get too much pressure, our system's going to explode, and we don't want that. So pressure relief valve, we've got solenoids controlling it. In this system, we've got a few little filters as well. So in most of our fuel systems, we've got filters. These ones are just in the fittings. And we've got pressure sensors as well. And we've also got our little injector at the end. In the CAT system, it's part of that ARD head. And you can't buy them on their own, as far as I'm aware, from last I checked. So pretty much fuel system, same. Pump, pressure relief valve, lines, filters, solenoid, injector, pressure sensor. You troubleshoot it like any other system. You got to make sure you have pressure there, otherwise nothing's going to work. And our solenoids need to be opening and closing. So this is a little bit more of a breakdown of what everything looks like. So these are our solenoids here, number 6. This setup here, this particular image is just coming off the normal system. So the one that we looked at before, this one's got its own little electric pump. This system here is just coming off our standard fuel system. So it's got this little module on the side here, which then directs it over into our after treatment fuel system. So that little one here is called a diverter valve. So it's diverting that fluid off into that system. Also, this is our little fuel rail. So some of our fuel rails will have 2 solenoids on them and 2 pressure sensors. So we've got pilot and main. Not all systems have pilot and main, but some of them do. They pretty much still both work in the same way. I'm just looking at, we're kind of running out of time a little bit, and I wanted to touch at least a little bit on AdBlue systems and on SER. So I'll just go through this a bit quickly. And then we've got our spark plug. So pretty much our spark plug is like any other spark plug on motorbike, car, all has the same components. We've got our coil, our ignition coil, and then we've got our spark plug lead, and then we've got our spark plug in our ARD head. Our spark plugs on our ARD heads are slightly different. They don't earth out on themselves, but they earth out, so they arc to a little thing on the ARD head. So if that little thing on the ARD head warps or anything, you will get a fault in there. All right, so we won't go into this too much. Some of our ARD heads have coolant lines going to them to keep them cooler, so that fuel doesn't heat up, as well as that combustion air doesn't heat up, and the spark plug stays in operating temperature. All right, this is a little bit on cleaning. So we touched a little bit on cleaning as we go through. So here are the few devices that we have to like properly or formally clean our DPF. So this one is kind of the portable version. And number one here is our kind of standard version, or like if you have a shop that has a cleaning device, you'd have this. It has like ultrasonic vibrations and stuff that shake the ash loose in there. All right, diesel oxidization catalysts. Cool. So catalysts have been used on cars for forever. But the reason why they couldn't just whack a catalyst on a diesel engine is because the chemicals that come out are slightly different, and it doesn't create the reaction that as easily as a car engine does, or a petrol engine. So what a catalyst is a substance that takes part in a chemical reaction without itself undergoing any change. So it's pretty much just like a precious metal. Most of them are a precious metal, and they can take part in a chemical reaction to change one chemical to another chemical without itself undergoing any change. So in a perfect world, a catalyst should never have to be changed because it should just stay there as is, just kind of chilling and everything's happening around it. So we're going to skip past this a little bit, but pretty much during a passive regen, we have our NOx and it can change into NO2 depending on, there's heaps of different types of catalysts. So depending on what metal they're coated in, they can convert one chemical into another chemical, or less. The idea is that they convert it into less harmful chemicals, usually oxygen and water. All right, SCR. So selective reduction catalysts are what we call, for some reason, they're what we call the catalysts that reduce NOx. So we've got DOCs is our common type of catalyst, so diesel oxidization catalyst. And the point of our diesel oxidization catalyst is to catch and convert any extra hydrocarbons. So hydrocarbons are our diesel matter. So we want to convert any extra fuel that's coming out into oxygen and water, I'm pretty sure it converts it to. But our selective reduction catalyst is what converts our NOx into less harmful chemicals, which I can't remember off the top of my head what they are. So SCR needs, or selective catalytic reduction to convert NOx, needs extra things as part of this process. So we're talking a little bit before about how catalysts have been used on petrol engines, but not on diesel engines, because the chemicals that are coming out of the exhaust pipe aren't exactly right to create that chemical reaction. So to convert NOx using SCR, which is it's coated in rhodium, it needs AdBlue. So what AdBlue is pretty much is, or DEF, whatever you can call it, is ammonia. So pretty much it's water and ammonia. Let's see, we've got a little bit. Yeah. So, or urea. Blah, blah. All right. So diesel exhaust fluid is 67.5% deionized water and 32.5% urea. And what happens is when that's injected into the exhaust stream, the water evaporates, and you're then, so down here, urea under heat decomposes to ammonia and carbon dioxide. So ammonia is what the rhodium needs. Let me go back here. So our rhodium catalyst needs ammonia to then convert NOx into less harmful chemicals. So in our component systems of, or in our AdBlue systems, as we refer to them, it's pretty much just like another hydraulic system whacked on there. So a lot of people kind of get caught up in like the magic happens, but realistically, if you really break it down to the simple parts, it's just a little hydraulic system. You've got a tank, you've got a pump, you've got some valves, and then you've got an injector, which injects it into the exhaust stream. Like anything, we need to make sure it's not blocked, and all that kind of stuff. With that, so AdBlue, we went through that. So our diesel tank is generally plastic tank with a blue cap. So we got different colored caps for different fluids, and blue is for our AdBlue. Sometimes they have a fancy filler neck, which doesn't allow, you need like a special nozzle to fill it to prevent customers from putting diesel in the AdBlue tank. People are still able to put AdBlue in the diesel tank, but yeah, the idea is that some of them will then, cross it over because, people. Yeah, so the idea, we don't really want anything in a metal tank or our AdBlue in a metal tank because it can corrode away. All right, so our pickups. So our DEF pickups into our tank generally have four lines going to them. Two of them is for DEF in and DEF out, and two of them are for coolant in, coolant out. So the idea of the coolant going in there isn't to cool, but is to heat it up. So we don't want our DEF to freeze. We want it to stay nice and warm and flowing. Otherwise, we'll have issues in that department as well. And also they've got a sensor on them. So I think in this one here, you can kind of see a sensor. Some of them have ultrasonic sensors. So it's sending a signal down and then vibrates back up, and it tells the sensor how much, or the sensor can calculate how much DEF's left. Or they have like a magnetic float that goes up and down, just pretty similar to petrol tank, but then sends a signal back on how much DEF there is left. Some of them are also smart enough to be able to pick up the quality of DEF in there as well. All right, so we've got our little pump. So our pump does a few different things. Our pump controls, depending on what type of system it is, our pump controls how much DEF goes to our injector. Some of the pumps also control the timing, but then we can also have injectors that have a solenoid on there that control the timing of the diesel exhaust fluid injection at like the exhaust point where it enters. And some of it control it from in the pump unit. But our DEF pump also creates a vacuum to then draw the fluid in or pushes the fluid out. So the idea, so this is called purging. So on the CAT systems, or on most heavy vehicle stuff, we've got a purge light now next to our isolator. So what that is if our diesel exhaust fluid is left in the lines, it can crystallize as it warms up, the air evaporates, and it sits there and it crystallizes it and it blocks it. The idea is that we need to purge all the DEF out of the system, so then it doesn't crystallize while the machine's sitting there overnight or over the break. So there's a few different ways depending on what type of injector you have on there, which we'll go in a minute. Put the injectors on here. Some of those pumps are built into the tank, so it's like one unit tank and pump. And like some systems just have tank, simple tank, and then pump mounted somewhere else with lines going to it. Cool. So injectors or doses. So like I was saying before, there's two different types of doses or injectors. So we've got injectors that have their own solenoid on there, and then we've just got injectors where all the timing or doses that all the timing and everything is controlled at the pump. So with a system like this, generally when we're doing a purge on it, air will be blown through. So if the system or the machine has an air compressor system on it for some reason, if it's got air brakes, it will generally blow air through and push all that diesel exhaust fluid out. So it's better to have it sitting in the exhaust pipe than it is to have it in that little line. And then we've got these ones here which have a solenoid on them. So on some systems or systems that don't have an air compressor, so they don't have air brakes or any other air systems, the pump will actually kind of reverse and suck it all out. So the idea is that it is reversing, sucking it all out. So then there's nothing left in there. So what that does also is when it's sucking it all in, it opens that valve so it doesn't create a vacuum. So it's opening the valve, sucking all the DEF in. It's also sucking some fresh in after it so it doesn't make a vacuum and crush everything. All right, then we've got our mixing tube. So depending on what type of system it is. So if we've got a CEM, so the clean emissions module, which is our DPF, our DOC, and our SCR all in one module. So cat guys, I think you should know what I'm talking about. They're generally like whacked on top of the engine and makes it really hard to get to anything else. They'll have the injector just like kind of sitting in the middle of that. But if it's just a standard where you've got unit, piping, unit, the DEF dosing valve will be in between there. It needs to have a certain amount of straight pipe for that AdBlue to then the water to evaporate, and then the heat reaction that comes, so then the urea turns to ammonia and then hits the catalyst. So there does need to be a certain amount of straight pipe in there. So if anyone does modifications on exhausts and they have any injectors in the exhaust, you need to make sure that, you know, there's certain requirements that need to be met for straightness or before a bend in those systems. All right, so when we have an SCR catalyst, generally we have an AMOX next to it as well. So what an AMOX is a ammonia oxidization catalyst. So pretty much any extra ammonia that's in the system that doesn't get used to convert NOx, it'll get caught by the AMOX and then it'll get converted to nitrogen and water, making it less harmful from there. All right, cool. I think, yeah, we're at 10 o'clock now. So I had some more stuff, which is just going into it a bit deeper. And then we almost made it to diagnose and repair. But anyway, from that, guys, so we're just going to kind of stop it there. So sorry for the last little bit being a bit rushed. I'm going to stop sharing. Oh, let me go back to seeing me. Not my PowerPoint anymore. All right, so yeah, sorry for that last little bit being a bit rushed. I kind of hung out on EGR and that a little bit too long. But I hope you guys got a bit of an overview of, you know, the systems, how they work, and, you know, just a little bit of kind of background on, you know, when you know how something works, it's kind of a bit easier to fault find it. Did anyone have any other questions? Or any comments or anything? Or anything, if you guys want me to do something on like 1 hour specifically on one of those, I know we kind of touched on everything, but if you guys are either working more or want more information on the AdBlue system, so that AdBlue system we can go on, like we can really break that down. I can almost talk about that for a whole day, but no one wants that. But if there's one system in particular in the emission systems that you guys want to just sit and focus on, just let me know about that, and we can do 1 hour on that system in particular, and we can go through fault finding, different parts. You know, all these systems have sensors and stuff that we didn't really go into too much, but we can really go into them in a lot more detail. Like I said, I usually go through this a whole day. Any cutaway images with the ARD head? I think I do have some of the ARD head. I'll note that down and I will see what I can find for you guys. I mean, I've got like 15 different notebooks. All I need is an empty one. Keen on more AdBlue? All right.
It'd be really cool if we could do like maybe like an hour or so course on kind of like diagnosis and repair.
Yeah. We can. I will note these down because we'll have some more. Like, I really want to do some more of these. I do quite enjoy talking technical.
Yeah, I've been pushing for emissions for 2 years now at my cat dealership, and they haven't put me through it yet, which is kind of annoying.
Where are you in Canada, Aaron?
Well, I'm in Maryland and how in America.
Okay.
Yeah.
All right, because I do know the cat trainer in Canada. I was just looking from your time zone, so it's just that's where I got a vague idea of where you guys.
Yeah, from Australia.
Oh yeah, based in Australia, so or was from Australia. So AdBlue, because yeah, AdBlue we can do like a whole thing on that, and then troubleshooting.
Is AdBlue what they call DEF in Australia?
Everyone bounces. I think the terminology that we use in Australia is a bit strange because we import everything. So depending on what country you import it from, the manuals are all in different things and people just chuck words out left, right, and center. So it's a bit of a funny one. All right, so cutaway images of the ARD head. I'll see what I can find, and I should be able to just post them in that cat, in our wrenching group. ARD cutaways. If I don't have any cutaways, I do know that I have a few other different images. What do we got? Sergio, they're different size. Is there any different size between AdBlue brand? So AdBlue is universal. So AdBlue actually, or DEF, has an international standard. It is always going to be 30. I know that I usually know them off the top of my head. Here we go. For some reason I've had a mental blank. Always going to be, 32.5% urea. And yeah, there we go. Yeah, it's always going to be 32.5% urea and 67.5% deionized water. That is an international standard. So if you do get anything that is different, then you need to like report them and like throw it in the bin straight away. Just don't even go there.
Okay.
Aaron, that's all right. Aaron, what did you have? You have another question?
I guess I didn't lower my hand. Sorry, my bad.
That's all good, all good. All right, guys. So thanks very much for coming to my first webinar. At the beginning, I know with you guys, I was talking about, putting a small fee on it. So if going forward, there might be a small fee, but I just wanted, so there was that guy who passed away. It was posted, the Caterpillar wrenching page posted that guy that had passed away and left behind, I think it was 1 or 2 kids. He had something fall on him, and there was a GoFundMe page for that guy's family. So if you guys just, instead of giving just as a little bit of a contribution to that cause, if you guys wanted to donate towards him some small amount, that would be really great. We had an issue with the Tier 4 final data link system, some random codes, anything on the data link system. I don't have anything in particular on the data link system, but we will go through that in the troubleshooting. We'll go deep into that. The data link system on the Tier 4 side of things is pretty strange because you can have an open circuit that will then give you random codes like abnormal updates, NOx codes, this code, that code. An open circuit or a shorted circuit brings up some really, really funny codes. So just with your, just gives you a huge code for you to figure out. Yeah, so when it gives you a huge code to figure out, go back to your basics. As a general piece of advice, just go straight back to your basics. Check your plugs, check your, check open, closed circuit, short to earth. With those massive codes, more often or not, it is a basic, back to your basic open circuit, short circuit kind of thing. Not saying every time, I do know there's other times, but yeah, just go back to your basics. Oh, good. All right, did you have another question? Sergio?
Yes. I have a question.
Yeah.
What about the diesel quality? Is it
the diesel quality? Yes, the diesel quality really does affect it because those emission systems, the after-treatment systems are relying on the chemicals to come out the same each time. They're really set for the diesel standard with the ultra-low sulfur diesel. That is 0.00015% sulfur maximum. What are the target values? All right, we'll go with the sulfur. Yeah, so the diesel is really, really important in that. So if the diesel quality isn't good, you're going to get different amounts of chemicals coming at the other end. and your DPF and your SCR and your DOC are going to be like, what the hell is going on here? And they're pretty much just going to freak out, and you're just going to get codes and everything's just going to block up.
Okay, I got another one, please.
Yep.
What happens if a diesel engine have a leaking with the injector seal?
In the injector seal?
Yes. What happens
so you've
if
got
the diesel have a contamination? I don't know if it's correct.
So if you've got too much, if you've got diesel leaking into the cylinder?
Exactly.
Yeah, so then you're going to have too much diesel, and if you didn't have any after treatment on there, if you had that diesel leaking into the cylinder, you'd have lots of black smoke.
Exactly.
So what is happening is that the DPF is going to catch all that black smoke. It's going to, and that particulate matter, and it's going to block up a lot faster.
Okay, so it's going to work, but faster than the regular.
Yes, so it'll catch it a lot faster. So maybe, just throwing out numbers here, every manufacturer is different and every engine sign is different. But some engines do a regen roughly every 25 hours, or let's just check out 25 hours of operation is when they do a regeneration. But if you notice an engine's doing a regen quicker, so maybe every 10 hours or every 5 hours, then there's something in there that's adding extra particulate matter. So it could be leaking injector, it could be burning oil, so it could have worn piston rings, burning oil. So if you've got, that high, if it's doing regens more often, generally there's something wrong engine side, which is causing particulate matter.
Okay, thanks.
That's all good. All right. Data link, huge code. What are the target parameters for the EGR? So I don't have the target parameters for the EGR system, but it is different at every operating temp. So as the engine warms up, it's going to be different. So you would want to, the EGR system is generally closed as the engine is warming up because you want it to warm up quicker. And then once we're warm and we're operating, you're going to bring it down. If the engine's idling, we're not going to have any or not much exhaust gas going into the combustion chamber because our engine is running cold. As it's idling, it's got a colder burn. All good. Anyone else got any other questions? Alrighty. So if you do guys think of any other questions, if we're getting, so we'll do I'll probably have a webinar coming up again of the AdBlue system. So just focusing on that system, the different components, and then we'll do a troubleshooting one as well. But if you guys got any questions, you can post them in the wrenching group. And if we do kind of get the same questions over and over again, I will just organize another webinar because it'll be a bit easier and you guys will be able to ask a few more questions. I can show you some pictures and describe things a bit easier that way. Yeah, so guys, I hope you enjoyed it. I'd love any feedback that you have. So if you just want to chuck me a message about that. And yeah, I really enjoyed running this for you guys. So if, ask away. I love technical training. And I really love helping you guys with exactly what you need, because I know in some places it is really hard to get training. Like Aaron said, he's been pushing for training. So I do know it can be. Yeah, thanks for that, Reese. Yeah, so if you guys got any questions, all good, Shandy. So also I do know other stuff, so I can teach other topics as well. It was just the emission system one seemed to be the highest questions coming in. But yeah, we'll just keep, like, if I notice any more particular questions coming up over and over again in that wrenching chat, we'll just organize another webinar or something like that. So thanks guys very much. Have a wonderful rest of your weekend, Australians. Enjoy your Anzac Day. All right.
Yeah, thanks a lot. I really appreciate it.